Hello students, in this video I am going to talk to you about structure determination from the given SN2 reaction, MS and 1H NMR data. Okay, so the question at hand, we are given an SN2 reaction of molecule A reacting with sodium cyanide under SN2 conditions. A molecule A has got a M by Z mass spectrum peak of 206 and 208 M, which is the M plus and M plus 2 peak in 1:1 ratio. It gives you the molecule B on reaction with sodium cyanide, and the 1H NMR is also provided for molecule A. Okay, the NMR data for molecule A is given as follows. It shows a 12H doublet at 0.8 ppm, a 2H multiplet at 1.2 ppm, 4H triplet at 1.8 ppm, and 1H quintet at 3.0 ppm. Okay, so now first of all, we have to decipher the MS data and the SN2 reaction. The MS data of molecule A shows the M plus and the M plus 2 peak at 206 and 208 in equal ratio. So which means that molecule A has got a single bromine atom, right? Now let's look at the SN2 data. It tells us that this bromo compound, when reacted with sodium cyanide in an SN2 reaction, gives this molecule B, whose molecular formula is given as C10H19N. Now we know that in an SN2 reaction, when a bromo compound reacts with Cn minus, it gives you the cyanide compound, or cyano compound, right? Or RBr plus Cn minus in SN2 conditions will give RCN plus Br minus. So in this case, we can write down the molecular formula of molecule B as C10H19N, as can be written as C9H19Cn. So which makes R is C9H19. So which makes our SN2 reaction C9H19Br plus Cn minus will give you C9H19Cn plus Br minus. So which means molecule A is C9H19Br, and this satisfies the given molar mass of 206, this formula. So now we are confirmed that molecule A is C9H19Br. Now we have to determine the structure from the NMR. Okay, so before we do that, we look at the degree of unsaturation of molecule A by the formula du is equal to 2C plus 2 minus H minus X, where C is the number of carbon atoms, H is the number of hydrogen atoms, X is the number of halogen atom, in our case bromine. And we do the calculations, we get du is equal to 0, which means the molecule does not have any double bond, triple bond, or any ring, no unsaturation there, except maybe single bonds. Okay, so the molecule has got only the saturated alkyl bromide. Okay, so now we look at the NMR data. We can see HA, okay, it shows a shift of 0.8 ppm. It's 12H in integration, very likely 4 methyl groups. Okay, now HB is 1.2 ppm. It's 2H in integration, and it looks very much like a 2 into CH. I'll explain that further, how I came to that. And HC is 1.8 ppm, right? And it's 4H in integration, and it's 2 into 2 methylene groups. Okay, very likely. And HD is at 3 ppm, and it's a 1H in integration. And from looking at its chemical shift, it could be very likely the lone, bromomethyl proton, right? So that's what HD is. Okay, and it's a quintet. Okay, so how do we interpret this NMR data? Okay, interpreting the NMR data, you see molecule A is very likely a symmetrical molecule. Okay, HA and HB are two sets of symmetrical isopropyl groups, sp3 protons at 0.8 ppm. HB splits HA as a 6H doublet on each side. Okay, HA thus adds to a total of 12H, both the sides put together. HC symmetrically placed two sets of methylene sp3 protons at 1.8 ppm, which is split as a triplet by HB and HD on each side. Okay, and HB is a symmetrically placed two sets of CH sp3 proton, which is a part of the isopropyl group at 1.2 ppm, which is split on each side by 6 HA and 2 HC as a multiplet. Okay, and finally HD is a 1H proton at 3 ppm, meaning it's the lone bromoalkyl proton exactly placed in the middle of the molecule A. It is split by 2 HCs. Okay, by 2 HCs on its either sides. So total of 4 HCs are splitting, and that's why it's a quintet. Okay, so look at this. This is the molecule we got, 4-bromo-2,6 dimethyl heptane. See, look at HA. Okay, the totally 4 methyl groups there, and they are split as a doublet by HB. Now HB is a 1H proton, and it adds to 2H on both sides, and it is split as a multiplet by HC as well as HA. And now we see HC is split as a triplet by HB and HD, right, on each sides. It's a 4H triplet. Okay, and then HD, the lone single bromomethyl proton, okay, it's at 3 ppm, and it's as a quintet because there are 4 HCs on either sides, so it's a quintet. So this molecule is confirmed as, okay, 4-bromo-2,6 dimethyl heptane. Thank you and have a nice day. Bye.